In this session of Tech Talks, we explain the basics of data storage in Dragonfly. A basic understanding of these terms and concepts provides an important foundation for understanding how data is stored and viewed within Dragonfly. All data is stored in tables in the database. Each type of data has its own table. For example, there are tables for point-of-sale records, the individual line items included in each sale, customers, vendors, products, product orders, etc. Here is a segment from a typical point-of-sale table. Each table is made up of multiple rows, with each row representing one instance of the object stored in the table. In this case, there is one row for each recorded sale. Rows are also referred to as records. Each row then consists of multiple columns, which define the properties of the objects in the tables. In our example, the point-of-sale table contains columns for the date of the sale, the amount of the sale, the payment types, etc. Columns are also referred to as fields. Each table contains a column that holds the unique identifier for each record. These columns are referred to as the primary key for each table. These identifiers are simple integer numbers, which are automatically assigned by the program as the records are created. They are unique within each table and never change. Most of the tables contain columns that relate the rows in that table to rows in other tables. For example, rows in the point-of-sale table contain a customer ID column. The ID numbers in this column match the primary key value of the sales customer in the customers table. These links are referred to as relationships. These relationships allow us to store the data for an object in one place, rather than repeating it every time it's used. In our example, a customer's information is stored in one record, which is referred to by every point-of-sale record for that customer. The Dragonfly database contains a data dictionary that defines all the tables, columns, and table relationships. This dictionary allows you to create detailed reports with data from one or more tables, without having to understand the complexities of the underlying data structure. The tables, columns, and relationships are all given user-friendly names, and the relationships between the tables are shown by arranging the tables and columns using a series of folders and subfolders. We'll see how this is done in the Tech Talk on data layouts.